Thank you for tuning in to Astro TV, your international news source for breaking astronomy and cosmology reports. We're glad you can join us on such a momentous day in cosmology research history, as a multi-decade-long endeavor in search for extraterrestrial life has taken its first step towards understanding a second Earth. After years of hidden research, NASA has launched and revealed an advanced technological breakthrough in spaceflight called Milkman that is capable of reaching the far corners of our Milky Way galaxy within only a few years. Its first mission will analyze the possibility of one particular extrasolar planet and its capability of supporting life by examining the surface composition of the planet and determining whether water exists on or underneath the surface. Joining us now is the lead scientist of the Milkman research team, Dr. Mason Roberts. Welcome, Mason.
Thank you, Derek. It's a pleasure to be featured on your show. We're really excited to share with you the amazing feats that we've done with scientific achievements.
You guys definitely have a lot to be proud of. So first off, Mason, it has been previously known that older spacecraft would take upwards of 20 years traveling at the speed of light to reach one of these extrasolar planets your team has in mind. How has your team been able to break this light barrier?
That's a great question, and I'll get to it shortly. But first, I'd like to introduce one of the specific instruments on the scientific mission called the gamma ray spectrometer.
That sounds interesting. We're hoping to learn more about the means by which the spacecraft will be traveling. Can you elaborate more on that?
Elaborate on the device? Of course, my apologies. Cosmic rays, charged particles, from outer space strike the nuclei of elements on the surface of the planet.
And how does the planet power
I'm getting there. The elements in the soil then re-emit high-energy photons called gamma rays with wavelengths specific to the types of elements that emitted them, as can be seen in this video. With such sensitive instruments, we can discern between different known elements on the surface, and their abundance as well. And used in parallel with neutron detectors, we can locate water.
Yes. We're all fairly caught up in the technologies of the gamma ray spectrometer, mainly because we've seen its use on the Mars Odyssey mission in 2001 that involved searching for chemical concentration and distribution on Mars' surface. Its involvement with the Lunar Prospector mission in 1998 that searched for potential resources, including water, ice, minerals, and certain gases on the Moon, and the ongoing Mercury Messenger mission that is searching for answers to questions regarding the elemental composition of Mercury's surface and its geological history. We're hoping for more information regarding the Milkman spacecraft and how it will achieve the monumental spaceflight that you guys have planned.
Oh great, well I'm glad you guys' reputation as TV's leading source for astronomical news is certainly well deserved. I'm glad everyone is fairly caught up. However, there are some specifics about each of those three missions that should be brought up. First off, Mars Odyssey GRS was specifically used to quantitatively determine the elemental abundance of the Martian surface, map the distribution of water on the planet by inferring from the distribution of hydrogen, study the low-level surface rock layering patterns, and determine the depth of Mars' polar caps. In addition, the Lunar Prospector mission used its GRS to provide global maps of elemental abundances on the lunar surface by recording and analyzing the decay of elements contained in the lunar crust. It was used to determine the surface elements of Mercury by observing gamma ray bursts of the depth of 10 centimeters and analyzing different elemental ratios in order to better understand the formation of the planet.
That's really great, Mason. Now I'm assuming you're going to tell us more about the full history about the GRS and how it went through several instrumental changes throughout the past couple of decades, mostly how the more modern spectrometers use automatic stabilizers for each crystal in the detector, how improvements in computer processing have improved the reduction of data noise, and how the new methods for displaying the data has helped scientists better understand mission results.
Actually, no. Just in case your viewers weren't convinced that the gamma ray spectrometer is an exceptional and useful piece of scientific equipment, I was going to elaborate more on the outstanding successfulness of each of those three missions. The Mars Odyssey GRS was extremely successful in mapping the elemental distribution on the Martian surface, discovered vast deposits of ice located just under the surface of the poles of the planet, and proved to be a huge breakthrough for planetary sciences. This Lunar Prospector GRS produced great elemental lunar maps that are essential to understanding the composition and history of the satellite, and was successful in identifying high concentrations of iron and mapping the location of creep, potassium, rare elements, and phosphorus-containing materials, essential for understanding and analyzing lunar evolution. And lastly, although Messenger is still in its core phase of its mission, initial results from the GRS have already proven to be successful in helping scientists analyze surface composition. The potassium-thorium ratio of the Mercury surface was analyzed using the GRS results and were found to look similar to that of Mars, implicating that certain previously accepted models from the formation of Mercury are no longer valid.
That sounds really great, Mason. That sounds really great. We'll definitely have to look into that. Thank you for your time and for coming out on such a momentous day. I'm sure my viewers quite enjoyed that.
Thank you, and actually I have a short bibliography that if any of your viewers...
Right, yeah. I'm not sure that will be necessary, but thank you, sir. Good luck to you and your team.